Evidence of ancient rivers spotted on Mars, study says. Researchers are reading the rocks in the history they show on Mars to paint a picture of when the planet supported liquid water on its surface billions of years ago. New highly detailed images and data of exposed cliffs on Mars reveal the first evidence of rivers that existed for more than 100,000 years on the Martian surface 3.7 billion years ago, according to a study published Tuesday in the journal Nature Communications. An international team of scientists used imagery and topography captured by NASA's Mars Reconnaissance orbiter's HiRISE camera to study a rim of the Hellas Basin in Mars' southern hemisphere. The Hellas impact crater has long been of interest to researchers because it's one of the largest in our solar system, stretching 5.6 miles from crater floor to rim. Here, ancient evidence of a large lake, rivers, deltas and channels can be seen in the rock. And the rocks reveal that Mars must have had a sustained and significant water presence in its past. The researchers narrowed their focus to a rocky cliff, about 656 feet high, twice that of the famed White Cliffs of Dover along the English coastline. There, the rocks are 3.7 billion years old. Composed of sediment accumulated over time, they're like the rocks found on Earth that were formed by rivers. These exposed cliff faces on Mars reveal rivers that continuously shifted their gullies, creating sandbanks similar to the Rhine or the rivers that you can find in northern Italy, the researchers said in their study. It is not like reading a newspaper, but the extremely high-resolution imagery allowed us to read the rocks as if you are standing very close to the cliff, said Francesco Solis, study author, geologist at Utrecht University in the Netherlands, and senior scientist at the International Research School of Planetary Sciences in Italy, in a statement. Unfortunately, we don't have the ability to climb, to look at the finer scale details, but the striking similarities to sedimentary rocks on Earth leaves very little to the imagination. The sedimentary rocks record layers of history, and the researchers were able to determine that the channels of these ancient rivers were around 9 or 10 feet, or several meters, deep. Analyzing these layers on Mars can shed more light on its history, much like geologists used sediment layers on Earth to understand how our planet evolved over time and envision what it was like millions and billions of years ago. Now we have the technology to extend this methodology to another terrestrial planet, Mars, which hosts an ancient sedimentary rock record which extends even further back in time than our own, said William McMahon, study co-author and a geologist at Utrecht University, in a statement. Of course, the rocks they were able to study from the orbital data only contain a fraction of the time that water and sediment was being moved in the region, the researchers said. Erosion is a powerful force, and it can erase layers of history in rocks. But other rocks acting as markers of time could be undiscovered or buried, they said. But they say they feel lucky that they were able to study this particular cliff face, which was slanted at the right angle, so the orbiter could capture it just so. That angle allowed the researchers to see what they refer to as stacking patterns in the rocky deposits and landforms created by the ancient rivers. They could pick out where the sediment changed and hypothesize what created the different layers. Based on the evidence they found in the orbital data, the researchers believe that the planet's water was driven by precipitation, like the rain we experience on Earth, and had a sustained presence 3.7 billion years ago. Previous studies of ancient water on Mars also suggest that it was prolonged, and this new research adds to that camp, while suggesting the fact that a significant amount of water was part of the Martian landscape billions of years ago. Such perennially flowing rivers would require an environment capable of maintaining large volumes of water for extensive time periods, and almost certainly necessitated a precipitation-driven hydrological cycle, Solis said. This is more in line with slower climatic change and less in line with catastrophic hydrologic events. This kind of evidence of a long-lived watery landscape is crucial in our search for ancient life on the planet. Click subscribe to receive the latest news.